These objects have been out there for billions of years, and then just by chance the Earth and this object intersect. One will be large enough that will survive the passage through the atmosphere, that fiery passage, and it falls onto the surface of the Earth. And what we can pick up is called the meteorite. Very few of the things that actually fall are found. My name is Laurence Garvie. I am the curator for the Center for Meteorite Studies at Arizona State University, and I'm also a research professor in the School of Earth and Space Exploration. Meteorites fall from space onto Earth all the time, and these are precious old objects. These are objects that tell us about our early solar system. We need a place to keep them in a safe environment for future studies. And so the Center for Meteorite Studies is that place. This is a meteorite vault around us. Each of these meteorites really has a story locked up inside it, and our job as scientists is to unravel this story. Almost all the meteorites that fall are from the asteroid belt. When we look at the different types of meteorites, one of the most recognizable are the iron meteorites, because iron is rarely present on the surface of the Earth. It rusts. We now know that most iron meteorites are the cores of early asteroids. They're telling us about the formation of early planets. You imagine early planets that were forming and failed. Then we have the chondrites. They really tell us about the most primitive early solar system material that have not experienced as a whole melting processes and high heating processes. If we think of one of the most famous ones called Murchison, which fell in Australia in 1969, and when you open this thing up, it's black on the inside. It's full of carbon and organic materials. That was telling you that the building blocks of life can form in outer space in an environment and at a time that was even earlier than the formation of the Earth. Actually, it's interesting, when you break open Murchison and actually smell it, it smells odd. And what you're smelling is 4.5 billion year old organic compounds that are still evolving from the sample. We have meteorites from Mars and we have meteorites from the Moon. Nature has impacted the surface of Mars, ejected materials off Mars into space, some of which can eventually intersect with the Earth. So nature has brought back samples for us, and those are called Achondrites. And when we look at those, they are crystalline rocks. Some of the most beautiful meteorites that we have are called pallasites. If you look at them, there's this beautiful sea of gemmy green peridot crystals in a metal of matrix. And we think that they are telling us about conditions between the core of an asteroid, which is primarily metal, and the outside of the differentiated asteroid, which is primarily silicates. Every once in a while a meteorite lands, so to speak, in your backyard, and this happened here in the Phoenix area. This is once in a generation, a falling in our local environment. For lack of a better word, it exploded above a remote part of eastern Arizona. This was the first time I participated in a meteorite fall recovery. What we were looking for here was something that looked out of place. Because we were in high mountainous regions, there were pine forests, there were oak forests. This was a really remote site. We hunted for about 132 hours in total. As soon as you came across this rounded, black fusion-crusted rock on this reddish ground, it completely stood out. First thing we do is to lift it up, very excitedly, by the way. I mean, you cannot imagine the excitement of finding your first meteorite. This stone turned out to be really amazing. So when we looked inside, it had structures that I hadn't seen before. It has like a crushed texture to it. It has the chemistry of a chondrite. So what is this telling us? So now we're starting to do the scientific work. What we do is we look at these meteorites and we look at their characteristics and their chemistry and their isotopes and their structures. And what we're trying to do is piece this all together to really unravel the early solar system story. When we look at our current solar system, why does it have, the rocky planets near the sun, and then we have the asteroid belt, and we have the gas giants? How unique are we? We're always hoping for the next thing to fall, the next thing that's different and unusual.